Hi guys, let's work some problems from lesson 3-4. Number 1 says graph the line, and this is a direct variation. And so what we can see is we have y equals kx. In this case, k is 4. There is no plus anything out here, and so we know it's going to go through the origin right here. And then we know also that the slope is 4. And that means that for every 4 we go up, we are going to go over 1. And so I'm going to go up 4 and over 1, up and over 1 like that, and connect my line. It looks like this. This can be my first point, and place my second point here and check it. Got it. Number 2 says, for each equation determine whether it shows a direct variation. If it does, find the constant of variation. So what I can do is I can look at it like this. If I have 2y equals 14x, and a direct variation will always be y equals some number times x, I can actually put this one in that form, y equals 7x. And so, yes, the constant of proportionality is going to be 7. So we actually do need to rearrange it. This one, I can tell because of this 9, actually, that is not going to be, and I'll kind of just show you why. So if I want to get y by itself, and you don't actually have to go to all this trouble, if you can see that the 9 is not going to combine with everything. So I end up with y equals 8/7 x minus 9/7. Okay, so this much of it would be a direct variation, but this part of it disqualifies it. It means it's not going to go through the origin, and it's just a little more complicated, so we're going to say not. So this one is 7. Oh, okay, hang on. Let's see if it'll actually do it. 7. And it's going to make me type it. Okay, and this one is not a direct variation. Check. All right, for each table, determine whether it shows a direct variation. So remember how we had y equals kx, and if I solved for k equals y over x, which just means I just have to put the y over x to get the k. And so we're going to just put these y's over their x's to see if we get the same k all the way down. So we're going to have 4 over 2, that's 2. We're going to have 8 over 4, that's 2. We're going to have 16 over 8, that's 2. So my constant of variation, we could actually write an equation for this. And so this is a direct variation, and it says write its equation. Okay, so that's what we're going to write right there. All right, in the next one we have 5 over 4, 6.25 over 5, and 18 over 8. And the easiest way to compare these is just to type them in your calculator. So you're going to go 5 divided by 4 is 1.25. 6.25 divided by 5 is 1.25. And 18 divided by 8 is 2.25. So that is not a direct variation. They have to all be the same. So this was yes. And we have y equals 2x, and then this one was not. Number 4 says, suppose that y varies directly as x. Every time we see this phrase, y varies directly as x, they will never say constant. You just have to memorize that. Y varies directly as x. So we know we have this y equals x thing going on, but there's going to be a number, a constant, that tells us how steep our line is, basically. And we know that y is 24 when x is 15. So again, if we solved for k, our k is y over x. So we don't have to do more work than actually just plugging in y over x. In this case, we have 24 for y and 15 for x. We can simplify that, which is 8 over 5. I was being lazy. And so we have y equals 8/5 x. And then we can use that equation to plug in x equals 2 to find out what y is. So y equals 8/5 times 2, or we're going to get y equals 16/5. Okay, let me see if I can remember that. Okay, and we had y equals, I think we had 8/5. And x, unless I got it backwards, upside down, nope. All right, for number 5, we have a physics problem. For a moving object, the force acting on the object, let's call that F, varies directly with the object's acceleration. So force equals a constant times A, or y equals k times x. When a force of 28 newtons acts on a certain object, the acceleration is 4. And so I know that my constant is going to be 7, or I could just put that y over x. If you forget what order it goes into, it's kind of good to do it the way I did it. So my equation could be f or y equals 7 times a or x. And it wants me to use that. If the force is changed to 63 newtons, what's going to happen? Well, what if I have 63 equals 7a divided by 7? And I'm going to get that a, the acceleration, is going to be 9. 7 times 9 is 63. So 9 is the acceleration. I think that's what it wants here. Good. And number 6, Amy is running. The number of minutes she has run varies directly with the number of calories she has burned. See the graph below. So see how calories is our x and minutes is our y. And how many calories is Amy burning per minute? So here we go. Calories, we want to know calories per minute. So let's say I go over 50 calories. I'm looking at this point right here. Over 50 calories in 5 minutes. And that would be 10 calories per minute. And what is the slope of the graph? So the slope of the graph is going to be rise over run, which is actually minutes over calories. So we could do 5 over 50. Whenever it comes out of the origin, we just can do y over x and get that slope of that graph. Whenever we start at a different place, we're going to have to just do a little bit more of the slope formula. But in these little bitty equations, they're actually a little easier. So we're going to say 10 and 1/10. 10 and 1/10. 10. So watch out on this one, what they're asking for, because it's easy to say, oh yeah, the slope and whatever this other number is going to be the same. Okay, so that was correct. So notice that we had to be careful because it asked us calories per minute, so I have to put calories over minutes. And then when it asks the slope, I need to do y over x, rise over run. All right, let me know if you need any more help than that.